Okay, so we're going to find the extrema of f of x equals x times e to the x. So that's the max or the min. First thing we're going to do is we're going to find the derivative. So we're going to use the product rule. So it's going to be x times the derivative of e to the x, which is e to the x, plus e to the x times the derivative of x, which is 1. So we want to set this equal to 0. So we're going to factor the e to the x out, and you're left with x plus 1. So if we set them each equal to 0, we get e to the x equals 0, and x plus 1 equals 0. Well, this can never equal 0, so there's no solution there. And then we get x equals -1 as a critical point. So we're going to do some test values for this to see if it's a max or a min. So from -infinity to -1, I'm going to choose any value, plug it into my derivative. It's the derivative, and it's going to be a negative value. And then from -1 to infinity, I'm going to choose a value and plug it into my derivative. And it's so we plug in a number between -1 and infinity and to the derivative, and it's positive. And so what that tells us is that it's decreasing and then increasing. So there's going to be a minimum at x equals -1. So to find the actual point of that minimum, we're going to plug in -1 to our function. So f of -1 would be -1 times e to the -1. And so we have the point, -1, negative e to the -1st. And this would be a minimum. Now, if we want to graph the function, then we want to see where it's concave up and concave down. So we're going to find the second derivative. So the second derivative of our function would be, we're going to use the product rule again. So e to the x times the derivative of x plus 1, which is 1, plus x plus 1 times the derivative of e to the x, so that's e to the x. So we end up with e to the x, 1 plus x plus 1, so e to the x, x plus 2. So we're going to set this equal to 0 to find our critical points for concavity. So e to the x again, when we set that equal to 0, it'll never equal 0, so no critical points there. And then x plus 2 equals 0, we get x equals -2. So we do another chart. This time we're going to do it for our second derivative. We're going to go from -infinity to -2, and then from -2 to infinity. If I pick a point on that interval and plug it into my second derivative, I get a negative number, so that means it's going to be concave down. I pick a point from -2 to infinity, I get a positive number, so it's going to be concave up. Now, as far as my end behavior, remember we can find end behavior by doing the limit as x approaches -infinity of x times e to the x. So if I'm plugging in a negative number, I have x over e to the x because it's going to be negative. So this is going to infinity faster than this one is. And so this limit equals 0 on the left side. However, on the right side, it won't be in the denominator. So positive infinity. This one will go to infinity. And so if I plot all this information, I know at -2, is a point of concavity. I know -1 is a little bit below here like this. That's a minimum. So I know it's concave down here. And then and at -2 it changes to be concave up. And so there's my graph.